The relation R on the set A, where A is a set containing the elements x belonging to the set of integers and x lies between 0 and 12. It is given by the relation R containing the set of ordered pairs A comma B such that the absolute value of A minus B is a multiple of 4 is an equivalence relation. That means R is an equivalence relation. This is already provided to us. We need to find out the set of all elements related to 1. That is the equivalence class 1. Okay, let us begin. Now, here we have the set A. So this is given to us. Let's note down whatever we are being provided with. Given the set A containing the elements x belonging to set of integers and x lies between 0 and 12. So let's list all the elements. That means we're going to express A in the roster form. So here we have 0, 1, 2. Going all the way up to the last integer, which is 12. Okay, and we have a relation R. R is the set of ordered pairs A comma B such that the absolute value of A, or we can say the difference of A and B, is a multiple of 4. This is a multiple of 4. Okay. Now, our goal will be to find out the set of all the elements that are related to 1. In other words, we have to find out the equivalence class 1. Now, what does it mean? According to definition, the equivalence class 1 is defined as the set containing the elements x. And what is x? X are going to be elements that are picked up from the set A. So x is going to be picked up from the set A such that we have x related to the number 1, or you can say x related to the element 1. Now, in other words, what we have here is we have to find out the set containing the element x. X is picked up from the set A such that, what does it mean when we said x are related to 1? Now, according to this relation, we have A is related to B. So this in short is also the meaning of A R B. But we need here x are 1. All we have to do is replace A with x and B with 1. That's going to give us x minus 1. The absolute value of x minus 1 is a multiple. It's a multiple of 4. We're going to use the definition. Now, we need to find out the value of x such that absolute value of x minus 1 is a multiple of 4. Now, absolute value of x minus 1, it's given here that it's a multiple of 4. Now, what are the multiples of 4? So, multiples of 4 are 0, we have 4, we have 8, 12, 16, and it is going to continue. These are all multiples of 4. And we are considering only positive integers here because absolute value is always a positive number. That means x minus 1, absolute value of x minus 1, this is always going to be greater than or equals to 0. That's why we're considering only positive values. Or in other words, we can say x minus 1 is going to be equals to 0, 4, 8, 12, 16, and so on. Now, let's do one thing. If we add 1 to each of these multiples of 4, then we're going to get the corresponding x value. So 0 added to 1, that's going to be 1. 1 added to 4, that's 5. 8 added to 1, that's 9. 1 added to 12, that's 13. 1 added to 16, that's 17. And these are going to be the different x values. However, we also have to make sure that A can only take the values such that x lies between 0 and 12. So here we can take only the values 1, 5, and 9. We have to exclude 13, 17, and all the other remaining values, which means that our set is going to be containing the elements 1, 5, and 9. So here we have successfully obtained the equivalence class of 1. So this is a set that contains the elements 1, 5, and 9 with the criterion that 1 is related to each of the elements such that if we take the difference, it's going to be a multiple of 5. We can verify that. So if we take this element 1 of the equivalence class and from it subtract one of the element from the set. So 1 minus 1 is 0. 0 is a multiple of 4. That's true. If we take 1 and from here subtract 5, that gets us negative 4. And we have to take the absolute values, which is simply positive 4. Yes, 4 is a multiple of 4. Then 1 minus 9, that's negative 8. And its absolute value, it's also a multiple of 4. So this is how we can obtain the equivalence class of 1.